Good afternoon, everyone. Welcome to the Virtual Tech Conference 2020. My name is Karan and I am the moderator of today's session. I will assist you with any logistical issues you may have. You could use this seeking follower option to seek help. Just change it to red and I will reach out to you for assistance. Also make sure to keep your microphones on mute. If you have any questions, you could post it on the QA panel. I'm monitoring the QA panel and would have the speaker responding to it as and when possible. We will run through a quick poll now to check if the audio is working on your end or not. Please respond to the poll. Okay, we have two people who are not able to listen. Okay, I will attend them. Let's start the slides now. If you're not able to hear the audio, please click the voice and video from live meeting menu and click join audio. Once your audio is okay, you should be able to see the speaker button available. You can see the icons on the menu bar. Check if the volume icon is working. Even if it does, you can select the necessary option from the feedback drop-down menu on the toolbar. To ask a question, type your question in the to ask the presenter a question, type it here and click ask field. Then click the ask button. If you want to watch it full scale, which we recommend to you, just press the key F5. Minimum resolution for 1024 and 768. In this session, MVP Prabhat Nigam, who is an expert on Exchange Server, will take you through the session Exchange 2013 Transport. Professional award. It is our way of saying thank you to exceptional and community leaders who share their passion, technical expertise, and real-world knowledge of Microsoft products with others in the community. I'm sure you will enjoy the session, so let me not take more time and hand over the session to our today's speaker, MVP Prabhat Nigam. Over to you.
Alright, thank you, Tadit. Thank you. Good morning, good afternoon, good evening, and thank you everyone for joining me for my session on Exchange 2013 Transport Architecture and Mail Delivery. Myself, Prabhat Nigam. I am a Microsoft Most Valuable Professional for Exchange Server. I write my blog at msexchangeguru.com. I'm a Microsoft Certified Solution Expert for Exchange 2013. I'm a MCITP for Exchange 2010 and 2007. I have worked for Microsoft Exchange Server PSS support group for a couple of years. And currently I work on consulting in Exchange and Active Directory projects. Alright, let's move on to the agenda of the hour. New transport architecture, transport services and ports, mail delivery, receive header, transport connectors, transport high availability, shadow redundancy, safety net, shadow redundancy workflow, transport high availability workflow, routing. These are our agenda of the day. Let's move on to the first topic: new transport architecture. So as you can see, there are three transport services are showing up in this screen. The first is front-end transport service. The client access server has this front-end transport service. So client access server can send and receive emails from internet using front-end transport service, which resides on client access server. Front-end transport service does AD lookup for closest healthy mailbox server to connect with transport service. So remember, it was front-end transport service. Look for healthy mailbox transport server to connect with its transport service, so that it can hand over the message to the mailbox server, to the transport service, without, it does not check any number, type, location, and message recipients. So basically, front-end transport service only proxy the incoming and outgoing mails. Front-end transport service also runs the connection filtering. Now move on to the next service, that is transport service, which is on the mailbox server. Transport service resides on mailbox server, where SMTP receive accepts the email and does the categorization, routing, send emails. Point to note that store driver has moved out of transport service. Now you can see the store driver is in the next service, which we'll discuss in a couple of minutes. Transport service can deliver the message to any other mailbox server, or it can send the email out to internet, or it can receive the email from the internet. So if you can see, the most important service here is the transport service. The next important service here is the mailbox transport service. So this is the third transport service in the suite of transport architecture. On the mailbox server, we also have the we can say this service also exists on the mailbox server, which receives the message on SMTP receive under the mailbox transport delivery service. Then it delivers the message to mailbox database. Similarly, mailbox transport submission service under transport service picks the message from outbox and then selects any mailbox server's transport service which is the closest within the AD site. So remember, it does not require to select its local transport service. So mailbox transport service can hand over the message to any other service transport service as well, whichever it finds healthy and responding immediately. It will hand it over to that server's transport service. Basically, mailbox transport service also proxies then email. The mailbox transport service on the mailbox server is broker between the transport service and the mailbox databases. The mailbox transfer service communicates directly with local database using RPC and with the transport service on local and remote mailbox servers using SMTP. All right, let's move on to the next slide. Transport services and ports. So as you can see, we have um, 4 services. So in the architecture, it looks like there are 3 services, but when you go to the server physically, you'll find there are 4 transport services: front-end transport, transport, mailbox transport delivery, mailbox transport submission service. Let us understand more about the services and ports of Exchange 2013 Transport. Front-end transport service runs on all client access servers and acts as a stateless proxy for all inbound and outbound SMTP mail flow. The front-end transport service doesn't inspect message content, only communicates with transport service on a mailbox server, and doesn't queue any messages locally. You can see there's no queue, nothing. It's just bypassing, just proxying to the next level. It's just transferring the messages to the transport service. Front-end transport service receives emails from internet on port 25 and 587 and from mailbox server on port 717. You can see here on the right side of the top of the front-end transport service, you can see on the right side it's a 717 down there. The message is coming from the mailbox server, and on the top you can see it's port 25 and 587. Sorry if it's a little bit not clear, the numbers. Alright, so front-end transport service also send outbound emails if send connector is configured to route outbound emails through the client access server. If client access and mailbox server roles are separate on different servers, then edge transport servers bypass client access server and communicates directly with transport service on the mailbox server. By the way, Exchange 2013 Edge Transport Server is back in Exchange 2013 Service Pack 1. Alright. Happy? Move on to the next service. It's Transport Service. This service runs on all mailbox servers. It is identical to Hub Transport Server role in previous server role in the previous versions of Exchange, except the store driver. The transport service manages the queue for all SMTP mail flow, performs message categorization, routing, address rewriting, message content inspection, journaling, write management, transport agents, DLP rules, transport rules, IRM policies. So most of the things you can see, everything happens in the transport service here. Unlike previous versions of Exchange, the transport service never communicates directly to the mailbox databases. The transport service runs the malware agent, which is enabled by default in the transport service on the mailbox server to help protect the organization from malware and other unwanted content. All default anti-spam agents run on transport service. By default, anti-spam agents are disabled, which can be enabled by running install-anti-spam-agents.ps1 PowerShell script in the script folder. The transport service routes messages between mailbox transport service and transport service and the front-end service. So the transport service component basically routes the email between the mailbox transport service and the front-end transport service. Obviously, it runs all the rules, so it you can say filters the mail and do the all the checks, all the agents, and then bypass or transfer to the front end or mailbox transport service. Transport service receives the message on port 25 and 465. When CAS and mailbox are on the same server, transport service uses port 2525 to receive the mail from CAS or to receive the email from the external clients or CAS or from any other SMTP server. Port 465 receives the email which came on port 587 on front-end transport service on the CAS server. Port 465 also receives the email from mailbox transport submission service. Interesting? Alright, let's move on to the next service, mailbox transport service. This service runs on all mailbox servers, which consists of two separate services: the mailbox transport submission service and mailbox transport delivery service. The mailbox transport delivery service receives SMTP message from transport service on the local server or on other mailbox server and connects to the local mailbox database using Exchange Remote Procedure called RPC to deliver the message. Mailbox transport submission service connects to the local mailbox database using RPC to retrieve the messages and submits the message over SMTP to transport service on the local mailbox server or on the other mailbox server. The mailbox transport submission service has access to the same routing topology information as the transport service because it's the same server. Like the front-end transport service, the mailbox transport service also doesn't queue any message locally. So a mailbox transport service will be the local service where the mailbox exists or where you have active mailbox server database. So wherever your database is active on that server, if you are sending email and you have a recipient on that server, then mailbox transport service will receive that message and deliver to the database. So it will not be remote service, but it can be, the transport service can be a remote service. Alright, now let's talk about let's have another review of the ports. Port number 25 is known as SMTP port, which is used by both external SMTP servers to send emails to the front-end transport and also from front-end transport to the transport service, unless they're together. Front-end transport or transport service use port to send outbound emails as well. So basically port 25 is used by both services, front-end transport service and the transport service, when CAS and mailbox server roles are separately configured. Port 587, I'm sorry, I'll talk about port 2525 first. Port 2525 comes into the picture if we have CAS and mailbox server role are together on the same server. Then the transport service will listen on port 2525 for all incoming emails in place of port 25. This is because of simple reason. The two services cannot run on same port. So when you install both the roles together, it becomes like two SMTP components installed on the same server, which cannot run on the same port. So that's why it uses port 2525. All right, port 587. This port is used for the client connection POP IMAP, which receives the email on the client access server front-end transport service. All right, port 717 is used for outbound proxies connections from transport service to front-end transport service. When you create a send connector, you have an option to send mail destined to the internet directly from transport service, or to relay through the front-end transport service. If you relay through front-end transport service, then front-end transport service receives the email on port 717 from transport service. Alright. Port 465 is used to accept proxy connections that were received on port 587 by the front-end transport service for client's connection. Transport service also receives the message from transport submission service on port 465. Port 475. The mailbox transport delivery service listen on this port for connection either from transport service send or SMTP from the transport service on the other mailbox server that needs to send mail to users on their server. Alright, let's move on to the next slide. Mail delivery. I'm going to talk about three scenarios here, three mail flow scenarios. The first scenario is when an internet user send an email to an organization mailbox. So if you are receiving an internet email from to your mailbox in your organization, then how will it happen? Let's review. So on the first scenario, the email will connect from the internet to our spam guard. This can be your Edge server or EOP or any other spam guard, Barracuda, or there are so many. Any spam guard, it delivers. Spam guard scans and then forwards the email to front-end transport service on port 25. Then front-end transport service look for the mailbox server in the same AD site. The preference is the closest closest mailbox server and the healthiest mailbox server. Then in front-end transport service transfers the email on port 25 if the cache and mailbox are on the separate server. If they are together, it transfers on port 2525. Then transport service does the filtering, run all the agent, transport rules, transport agents, DLP policy, everything, and then transfer to mailbox transport delivery service on port 475. Mailbox transport delivery service transfers to the store where the mailbox is. Remember, mailbox transport service will be local to the store. So transport service can take a decision on which server the mailbox transport service resides, and it has to transfer to the mailbox transport delivery service of that server. Let's take scenario 2, the mail flow scenario 2, where a mailbox from your organization is sending an email to the internet, how the mail flows. So from the store, from the mailbox database, the mail will go to the mail will be picked by mailbox transport submission service. Then mailbox transport submission service will forward the email to transport service on port 465. Then transport service will either send it directly if the send connector is not configured to use client access server, but in this scenario I'm configuring. So if we have client access server configured, it will send it to front-end transport service on port 717. Front-end transport service will send the email to the spam guard or directly to the internet. Alright, let's take the mailbox mail flow scenario 3, where one organizational user is sending an email to the other organizational user. Alright, so the store from the mailbox database, the mail goes to the mailbox transmission submission service. Mailbox transport submission service sends the email to transport service on any server within your DAG or within your AD site on port 465. Then this transport service transfers the mail to the mailbox transport delivery service on port 75 on the local for the local user, local mailbox database. Alright, and then mailbox transport delivery service transfers to the local database. This is all three scenarios. I hope this is gonna clear your doubts about the mail flow, how mail flow works in Exchange 2013. I'm also going to talk about these new Exchange verbs. So there are a few new Exchange verbs have added. When front-end transport service transfers an email to transport service, it does X proxy. X proxy from and X proxy to carries the info from where the message is coming. It says all the info, all the IPs, all the headers, it forwards to the transport service. And when transport service sends an email to front-end transport service, it uses X proxy 2. And it also carries the header, basically the IP, all routable information. All right, two more verbs has been added. When the transport service transfers the mail to mailbox transport, the two verbs come into the play, that is X session perms and X message context. So X session perms carries all session parameters, and X message context carries specific context of the message. All right, let's look at the receive header. How will it look like? So you have to see from the lower end. So the first header which will come is like this first part here, incoming mail on all in one role, kind of a which can be another scenario. The message ID, then the from address. Then the second header shows it's received from internet, and the cache server name, the domain.com, the IP, which is configured for Microsoft's SMTP TLS, and the version via, you can see the via front end transport. and which date. So it shows the which version of Exchange received it, which server received it, and which service received it from internet, and from which IP of the internet sent it. Then the third header information is it says that it's received from client access server, which is the same server from, and to received by the mailbox role server. All right, and the fourth header to shows that it's received by mailbox transport service. So you can see what all we have here is the Exchange version 15.0.775.3038, which seems the cumulative update 3 here, which service receives it, and which server received it. So it's all new header, new different header for Exchange 2013. All right, transport connector. Wow. So when installed Exchange 2013 for the first time, were you surprised to see so many connector? Well, I did. So then I went through and checked out all the connectors. So let's talk about connectors. There are 5 receive connectors which gets created by default, and I would recommend do not delete any default connector, because that can cause some problem, and every connector has a purpose. Here you can see I've explained the architecture. As per the architecture, you can understand that every port and every connector has a purpose. All right, we need to create a send connector to send emails outside organization. It does not come created. This is the organization level connector, which can add mailbox role server in the source servers unless we check the checkbox proxy through client access server. You can see on the screenshot I have taken from a send connector. If you check this checkbox, you can add the client access server in the source server of the send connector. All right, and if we check the checkbox, mailbox server will forward the email to the client access server on outbound proxy front-end connector. This connector operates on port 717. Now we will see 3 receive connectors on the client access server and 2 on the mailbox server. 3 client access server connectors are default front-end listen on port, default front-end connector, receive connector, which listens on the port 25 and receives email from internet or external SMTP servers. Then we have client front-end 587, which receives the email from POP or IMAP clients, accepts secure connection with the TLS. Alright, we already discussed about the outbound proxy front-end server, which is being used for send connector to send the emails out through the client access server. Then we will see 2 receive connectors in the mailbox server. The default receive connector listen on port 25 to receive the email from CAS or external SMTP. This connector changes the port to port 2525 if CAS and mailbox server are on the same server. This is the same situation if you look at your IIS and see, okay, we have both the servers together, and the IIS has 2 websites created, default website and the backend website. So the default website will work on 443, So the cache will receive everything on 443 and forward it to the mailbox server if there's a requirement on port 444, right? So it is the same way. The both the component, the HTTP, two websites cannot run on the same port. The same way, SMTP, two SMTPs cannot run on the same port. So we have 25 and 2525 in case both are merged together. All right. Then the next connector is client proxy receive connector, which listens on port 465 and receive emails from client front end receive connector of the client access server. This connector also receives the outgoing emails from the mailbox transport service. All right, let's move on to the next slide. So the next slide is transport high availability. The transport dumpster. So we'll talk about the why do we need the transport high availability? Because we already had the transport dumpster in the previous versions of Exchange. Transport dumpster is a great feature, but in case of the hub transport server crash, in case of the hub transport server crash, we lost the emails, and when we look around, we had DAG, we had CAS, we have Mailflow in high availability, but the mail queue were not in the high availability, which made Microsoft think, and now we have the high availability of the transport queue as well. All right. So let's talk about new high availability feature in Exchange 2013. In Exchange 2013, we have new high availability feature which works with DAG and non-DAG. In a DAG configuration, DAG is the transport boundary of this high availability. In non-DAG configuration, the Active Directory site is a transport boundary of this transport high availability configuration. We need minimum two servers to get the high availability. That's much obvious. We have the site resiliency. So site resiliency comes when it is on the DAG. Whenever it receives the email, it immediately copies to the second site. It does not go to the same site server. It copies to the second site to avoid any disaster of the primary AD site. All right, so shadow copy will create in the different AD site. It's more reliable. Mistakenly I wrote more reliance. It's more reliable because it has two copies and does not acknowledge until shadow copy is created. So, well, listen, yes, it does not send an acknowledgement until it creates a set of shadow copy when we do the mail flow. So new transport high availability is time based. Default is 2 days, same as message expiration queue. New transport high availability automatically recovers the emails, and we have a new verb coming in the mail flow, which is X shadow, which means the shadow copy is doing the shadow copy. All right, let's move on to the next slide. Shadow redundancy and safety net. Very interesting. So we all know shadow redundancy was in Exchange 2010 as well. So it is, shadow redundancy is almost similar to Exchange 2010. Shadow redundancy sends acknowledgement only after making shadow copy. If shadow copy of a message is successfully created, but SMTP between the sending SMTP server and the primary server times out. The primary server accepts and processes the primary message. Yes, even if the session expires and we have created shadow copy, still your incoming mail will be delivered. The sending SMTP will redeliver the unacknowledged message, but duplicate message detection will prevent Exchange mailbox user from seeing the duplicate message. Alright, this is another new feature. The duplication will be removed in the case of a session timeout, and if Exchange detects a duplicate message coming, which may not work in case when we send an email outside the boundary of the high availability. All right. Shadow redundancy works both in both DAG and non-DAG. DAG is another transport boundary, and then for a non-DAG environment, it's AD site is the transport boundary. By default, shadow redundancy is enabled. Let's check something on the safety net. So the safety net, what is safety net? Safety net is a new name of the transport dumpster. We all know transport dumpster, it was a great feature, but we have done some enhancement to the transport dumpster and given a new name, safety net, because this guarantees the delivery of your mail. I'm sorry. Safety net works for both DAG and non-DAG, same as the shadow redundancy. The DAG boundary is DAG boundary is across the site, and non-DAG boundary is within the AD site. Right. Transport dumpster. Okay, so I'm sorry. Okay, so the safety net creates the queues on the transport service. All right. Safety net provides redundancy by redelivering the message in case of loss in transition. Safety net is no longer a single point of failure. This introduces the concept of primary safety net and shadow safety net. If primary safety net is unavailable for more than 12 hours, resubmit request becomes shadow resubmit request, and messages are redelivered from shadow safety net. Make sense? In Exchange 2013, the transport high availability is more than just a best effort for message redundancy. Exchange 2013 attempts to guarantee message redundancy. Safety net does not have any size limit, but number of days is the limit, which we can set. By default is 2 days. Safety net is automated and no manual effort required. Shadow one more important thing I'm missing is shadow redundancy should be enabled on the for the safety net to work. So shadow redundancy and safety net works together. So first the shadow redundancy comes into the picture, and then safety net comes into the picture. All right, let's move on to the next slide. All right, this is the shadow redundancy mail flow. We will have a look here. In the first image, you can see that it is showing the exchange verbs when you type the command ehlo. You can see the last verb is the X shadow, which is the new verb added to the Exchange 2013. So now we can see the workflow of the shadow redundancy. The first thing is the external email sends a message to primary 2013 transport server. In this case, we are talking about the mailbox role server, because these safety net, shadow redundancy are works on shadow redundancy, and safety net works on mailbox server on the transport service. So here we go. The first external SMTP sends a message to primary Exchange 2013 transport server. Then point number 2, you can see Exchange 2013 transport service copy to shadow server. So this on the point number 2, you can see it is copying the message to the shadow server, and then the shadow server gives the acknowledgement that I have received the message. And at the point number 4, you can see the primary server is sending the acknowledgement back to the external SMTP. So you can see shadow redundancy does not delays, because basically I should say delays the acknowledgement of receiving the message, and it does not give the acknowledgement until it makes a copy of the shadow message. All right, let's move on to the next slide. Transport high availability workflow. So this is how transport high availability workflow works. A mailbox server receives a message from any SMTP server that's outside transport high availability boundary. The transport high availability boundary is the DAG or the AD site, active directory site. So it receives a message before acknowledging receipt of the primary message. The primary mailbox server initiates a new SMTP session to a shadow mailbox server within the transport availability boundary, and makes a shadow copy of the message. In DAG environments, a shadow copy server in a remote active directory site is preferred. All right. The primary server processes the primary message and delivers it to the user within the transport high availability boundary, or relays it to the next hop. Primary server queues a discard status for shadow server that indicates the primary message was successfully delivered. The primary server moves the primary message into the local primary safety net. Now the shadow server periodically polls the primary server for discard status of the primary message. When shadow server determines the primary server successfully delivered the primary message or relayed it to the next hop, the shadow server moves the shadow message into the local shadow safety net. The message is retained in the primary safety net and shadow safety net until the message expires. Remember, we talk about the number of days we configure. So it will, if you follow the default message expiry configuration on the safety net, it will remain for the 2 days. After 2 days, it will be removed from the safety net. Now we'll see an example in the next slide. So here's the example of the transport high availability workflow. All right, somehow the bullets it changed to the bullet. I will share my copy. This looks better here. So you can see in the first step, the inbound email comes from external SMTP to mailbox 01 server. Then in the second step, right away, shadow redundancy duplicates email to mailbox 03 server and delays acknowledgement. In the step 3A, we can see mailbox 01 is not waiting for the shadow copy. It's also processing the delivery. So you can see that in the step 3A, mailbox server delivers the email from transport service to mailbox transport service. The mailbox transport service delivers to the local mailbox database. And in 3C you can see mailbox 01 server queues discard status for mailbox 03 server for successful delivery, and mailbox 01 server moves the email into the local primary safety net. All right. On the fourth step, mailbox 03 server periodically polls mailbox 01 server for discard status of the primary copy of the email. And in the fifth step, mailbox 03 determines mailbox 01 server successfully delivered. Mailbox 03 server moves the shadow copy message into the local safety net. Alright, let's move on to the next slide. I hope this is very clear with this example. Routing. The Exchange 2013 have delivery groups, which is a way to generalize mail routing to help improve efficiency and attempt to deliver a message as close to its destination as possible. So a delivery group could be the DAG mailbox delivery group, connector source server, in an AD site, which can be the hub site, the Edge subscription. Remember, the Edge subscription, if it is subscribed to some mailbox servers, it will only send the email to those email servers, not all mailbox servers. So in that case, that's a delivery group for Edge subscription. DL expansion server. Who configures DL expansion server? I will never recommend to configure it, because this can cause the issues in case of the server goes down or anything happened to the server, or if you're patching the server is restarting, so I would never recommend to go for the DL expansion server delivery group. All right. Routing does the mailbox transport service to store delivery on the active mailbox database, which is the final delivery, and it prefers the local mailbox server, which is always the preference. The local nearest the mailbox transport service prefers will be on the local mailbox server. Bifurcation. The bifurcation of the message is the routing decision, which tells at which level we have to create multiple copies of the email. This is the point where a multi-user email needs to go to the different parts of the final delivery. This can be within the delivery group and out of delivery group as well. So at one point it decides, okay, now if you have sent an email to 10 users which have some internet users, some outlook.com users, some microsoft.com user, and some of your organizational users. So at the last point of your organization's transport delivery group, it will bifurcate the messages to different receive SMTP servers. All right. Then route calculation. Exchange 2013 routing calculation will look for minimum cost. So the first option is the minimum cost. So if there are two or more routes with same cost, then it checks the hop. And if there are two or more routes with same cost and same hop, then it will go with the alphanumeric routing, which will be the name of the AD site in the alphanumeric sorting, you can say. All right, let's move on to the next slide. So this slide is talking about the connection filtering. The connection filtering is is the anti-spam filtering, which does not come with a anti-spam script. So by running the install anti-spam agent.ps1, you will not find connection filtering, because connection filtering part of the client access server. It's not on the mailbox server. So we need to follow these steps to create connection filtering. So the steps are: open Exchange Management Shell as administrator, run the below command. This command is the main command which is going to enable this agent. Then you should know what are the other agents running on the client access server. Prioritize this agent as a first agent to receive, because at the first point you want to configure accept or deny for any connection based on the IP address. Then the next step is to configure IP block list provider. This is very useful. One of the org spamhost.org provide the IPs which you can block based on their analysis that which IP is spam, or anyone reports any spam. Based on that, they build a list and provides to every organization which subscribe in this way. So you have to run this command: add IP block list provider, name of the blacklist provider, lookup zone, and if it matches, enable it. Then enable the agent. Run the command enable transport agent and enable the connection filtering agent. Restart front-end transport service, and that's it. You are done with the connection filtering, and you can enable it. Alright, so we have come to the end of the session, and today's summary is: we learned about transport architecture, we learned about mail flow, we learned about transport high availability, we learned about transport connectors and services, we learned about transport ports. Alright, this is about me and my blog. You can send me the feedback of my session on Prabhat at msexchangeguru.com. My blog is msexchangeguru.com. We also exist on most of the networking channels: Twitter, Facebook, YouTube, LinkedIn group. So we have two LinkedIn groups: Microsoft Exchange Server and Microsoft Exchange Server 2013. I would encourage you to join there, and we always share the latest and greatest knowledge there. And you can also ask any question you have here, or on our website, or the LinkedIn groups. We are good in answering. Alright, with this last slide, I would like to thank you, and I would like to take your questions from here. Alright, SpamGuard will not bypass front-end transport service. SpamGuard, there are two ways SpamGuard can bypass, or we can bypass client access service, or we cannot. So whichever way we want to configure, we can configure SpamGuard to point to the client access server on port 25, and it will deliver to the client access server, which will be receiving on the front-end service. But if you want to bypass, you can directly send to the mailbox transport service on port 25 on the mailbox server. If you have both client access server and the mailbox server together, you can configure your SpamGuard to forward the emails to the same to the server IP and port 2525, and it will bypass the client access server front-end service. Alright, so thank you again.
I hope the audience have enjoyed the session and it was equally useful for them. I would like to mention here that feedback is important in planning the sessions, and request all our attendees to provide by participating in the research. This team
Thank you again.